Hey y'all, it's Crafty Coder here, wanting to do a Motobrain update. It's been quite a while since we last spoke. A lot has happened since then. I've started casting these guys, and right now we've got a silicone mold that we're casting into, and what it's giving us is this guy, which has a integrated heatsink on the top with lots of extra surface area, labeled all the outputs and the inputs, and potted it in thermally conductive resin. This guy has been tested up to 100 amps with excellent effect. So we are in excellent shape right now. I've got quotes out with several manufacturers, and I hope to have these things in production in the next few months. I've come a long way. Here is some of the earlier casting attempts. This guy, also thermally conductive resin, but I put an acrylic cap on it. But the mold was such that I couldn't actually get it to release, so it ended up getting all chipped and ugly. And I've got some better looking ones and some uglier ones. Those are on other vehicles of mine for road testing and stuff. But the good news is that the road testing works great. I sent one of these off to Australia, and a RV manufacturer has been doing some testing with it, and they say it's near perfect for their needs. So that's excellent news. One of the things that you might have seen here are these brass standoffs added to the design now. Are those standoffs so we can put on a little acrylic cover and insulate the terminals from anything that might rattle around wherever you install it on your vehicle. So yeah, we're in good shape. We have the exact same model as this guy right here attached to my testing station. So I thought we might go over the all the features one more time. You know, we can do things like turn on and measure current, right? That's easy. We can also tell a circuit to turn on with the ignition and turn off with the ignition. So we'll kill the ignition and we'll turn it on and turn it off. You can see there on the top, just to the right of the Bluetooth logo, the voltage. So when I turn it on, the voltage goes up to about 14 volts. When I turn it off, it goes down to about 12, which simulates vehicle ignition. We'll turn that back to manual. What else can we do? Of course, we can do stuff like PWM. We can dim. We also have inputs, or we can also just pull a shit ton of current. Why not do that? So that's 50 some amps, which is quite a bit. Oh, well, we don't want to do that with the ignition off. We'll start a fire on this diode. Let's see. Oh, let's test the inputs. So you may recall that we have these inputs now. So I've got this wire here set to 12 volts, and when I connect it, and I'm just dragging them across all those inputs. Now that's sort of interesting or whatever, but look what you can do. We can say input 1, when it goes to 12 volts, turn 1 and 3 on. And when we pull it off, it turns off. We could also likewise tell it to say, make it blink. Just that easy. So lots of features like that we can do. We also have analog inputs. So if we do that, now we can see that it's exactly 13.1 volts, and it floats at 0.3. So that's kind of the basic feature set, super condensed. You can do a lot of other things. There's also, of course, all of the circuit breaking and the overcurrent priority and stuff that we've discussed in previous videos. But we're really maturing in terms of feature set and reliability, functionality, and the thing's pretty durable now and incredibly effective at pushing current. So pretty excited. All right, guys, take care and hope to see you all soon. Bye.